Okay, welcome to this session. I'm going to talk about migration from Oracle Rdb to Mimer SQL. And I'm going to first start out with a little bit of background. Why would you do this? Why? And then I'm going to talk about a database migration kit that we made to make this really simple and help the customer get across to the new system. And then I'm going to talk about a customer case that we have in Mexico right now, where we're doing this migration at the moment. A pretty big system. And then I'm just going to talk about how you can do this and what various options you have. Oh, thank you. Okay. Well, let it get into the background a little bit. Mimer is a company. We've been working on VMS since I think we ported in 82 first to 780. And we've been on all the different platforms since then. And we have customers actually all over the world. So we have a lot of production systems running in Australia and Canada and the States and so on. We have a really strong R&D team that a lot of people have been working for a long time with this. We're really a tight group that can do anything together. Our headquarters is here in, let's see if I can, here in Uppsala here, and we're here now. So it's across the Atlantic. Okay. Okay, so why do you need to move from our Oracle Rdb? I saw that Kevin Duffy was giving a presentation, but once again, he's not delivering and he's not wanting to share what they've done with their customers. And that should worry anyone, I think. And the other part here is the cost of the product. The RDB is quite expensive. I mean, Oracle will continue to excel in this area. And also on the client side, they have a JDBC and an ODBC, but they've nothing else. So there's a lot to wish for in that respect if you want to build nice front-end applications to your system. And why would you move to Mimer? Many of the conversion kits presented by others, they actually move you away from VMS. Sometimes they keep the application on VMS, but they move the database away. But it's actually the other way around that makes sense. You would want to keep your database server on the super stable platform on the high availability system, and then have applications accessing that. And perhaps if you want nice front ends, maybe you don't want OpenVMS to be your client system. Then you could have that in the web or on Windows or other systems. We have a database that's extremely stable. We've built this from ground up so that it runs. You don't do any maintenance. It just keeps on running. So we have lots of production systems with high availability where that's really important. Another difference with RDB is that we're not using locking. And when I talk to people using RDB, they're always telling you about locking problems that they have. And you can also see this in the applications. You have to declare ahead lock modes, all sorts of stuff in your application when you work with systems. With Mimer, you just do the database operations and you can look at it. You don't have to say anything about locks or modes or anything. So it'll probably be faster in developing your applications. I've been at a couple of boot camps. I've presented the database. I showed figures about TPC-C and TPC-H. where we actually excel at transaction handling, where we beat Postgres and all the others. We've also shown when you have query intensive, like the TPC-H, where you're really testing the optimizer and aggregation and data crunching of the system, that we also excel in that area. So we can both do the query handling and the transaction with this system. Even though we're very big fans of OpenVMS, we actually run on everything. I mean, we have Linux and Windows and Mac, and we run on a number of embedded systems like VxWorks and QNX and more low-level systems like that as well. As it happens with the SQL that we support, is actually very compatible with RDB, I would say. We have everything that RDB has, that standard SQL, we also have. So actually moving across is not too bad. But I'll talk more about this. Another thing that I want to point out is that with the tools that we have now and the way that you do the transfer from RDB to Mimer, you actually keep your old source code. We actually modify your source code in a single step, but you maintain it as before. You don't get some other packaging or some other mods here or layers here. Or if you've been using embedded COBOL, you'll be developing embedded COBOL as you go on. If you've been using modules, SQL modules, then you can do that in your next step. So we kind of keep the same application environment. I think that's important for developers going forward to have this continuity. Okay, so that was a little bit quickly about background and why you do this. Let's take a look at the migration kit. So this is really a set of tools that we've developed to help do this migration. We've also written a migration guide where we really explain all of these things and why you do them and how you do them. But you don't actually, I don't think you actually need to read the migration guide to actually start doing a real migration. It also goes through what type of differences are there. There are some things, for example, in triggers, because RDB has implemented their own flavor of triggers rather than the standard implementation of triggers. And so, for example, if you have a row trigger and you want to modify the current row, that's done with an update statement in RDB, but you actually just modify variables in a standard procedure. So they're a little bit different, but these differences are not hard to have. Okay. So this is really what we have here. We have some kind of source code here, your source code today that's accessing your RDB database. And basically what we want to do is to move three things over. Well, we want to modify the source code so that it works with Mimer in the end. You want to move the database schema across with all the tables and constraints and indexing and whatever objects you have in your database. For example, some applications with RDB has been using a lot of domains. So it's really good that we also support domains in the same manner and so on. So I think someone that knows his RDB schema will be very comfortable in his new Mimer schema, because this is a lot of this just moves across. And finally, you want to move the data from the RDB system into the Mimer system. Okay, so the schema, let's take a look at this. So for example, when you export your schema from RDB, there's actually a script to help you do this. It goes into you just give it the name of the RDB database, and it will go into this. And when you do an RMU unload, which is the RDB utility to actually export the schema, it also gives you some system tables that we filter away at this point because you don't need them on the other side. This step you can do on the machine, and you actually have several options here when you do this conversion. You can do them all on your Itanium where you're running today, and you can move to Mimer on Itanium and do all of these things on that platform, or you could actually move them across to another platform like OpenVMS on x86 or even in Linux. So. And in the next step here, we want to translate these statements. With RDB, you have a structure with something called a database. And actually in Mimer, there's also something called a database, but they're not exactly the same. So typically, an RDB database is translated into a schema. And I've seen that other migration products also use this schema, moving to Postgres or SQL Server. That one database in RDB is actually becomes a schema in your new, because you want to do joins between different databases, and then you just do a join between data tables in two schemas. So when you do this, we translate the schema statements. So we're taking the output from the RMU, we're actually translating whatever syntax is used, and they have lots of, create table and storage maps, and they have lots and lots of things that are not really relevant, and we don't need them, and they won't help you, and they won't give you better performance. So we're getting rid of a lot of these parts. We're just leaving the standard SQL, create table, that type. Then we also go in and once we've built and set up the schema on the Mimer side, we actually run an analysis tool on the schema to optimize it. So we're analyzing indexes, for example, and the output from this utility, you can almost always use the suggestions that it's giving you. For example, if it says this index is not really needed, you can safely drop that index. It will not say that unless it can tell from other parts of the system. And this has to do with, sometimes there are implicit indexes because you have a constraint, but in RDB you may have an explicit index. So you would be getting two indexes on top unless you did this type of analysis. In other cases, it may be that two indexes are actually overlapping, then you can get rid of one of them. And so it's kind of fun when people run this the first time, they're actually getting good hints of what they could have done in their RDB environments because of the analysis tool. And then we want to import the data. So we have a script that kind of runs through all of these things. So you have one script getting it out of RDB, a second one moving it across, doing the analysis, creating the environment, and then importing the data, which comes in the next step. So this is kind of a little.
Any questions?
I'm done now. Here we were. Okay, so you're doing the RMU extract from RDB over here. You're translating the schema. You're creating it here in Mimer, and then you run the analysis on this, and then you actually take it. It actually produces SQL statements that you apply to do the optimization. So you can easily see what it's doing and go into these log files and then you do the data extraction here with the RMU unload, and you're actually using a Mimer load utility to get it into the database. Okay, so to do this, we're actually using 4 specific tools. The SQL translator is the new tool that we've developed to, actually, it understands RDB syntax. It has pretty much everything in the RDB manual in its grammar. A lot of that is to get rid of it, but some you keep and some you transform because they're not following the SQL standard in everything. So we kind of map this over to standard SQL. And then we have the analyzer that I talked about, looking at indexes and other things. And you have the meme load here that loads the data into the database. And for example, the output from the analyzer, you can use a command line based SQL to just do the optimizations. Okay. So if we look at the translator, it can actually work towards several types of files. So it can go into an SQL script file that's for RDB, and it will give you a Mimer script file as the output. Or it can go into an embedded COBOL program, and it will find your SQL statements, replace them, and give you a new COBOL program, or embedded FORTRAN, or modular SQL. So one part is just locating a specific state, but once you find it, I mean, the translation is the same, regardless if it's in a script or if it's in a program. So we support embedded SQL for COBOL, FORTRAN, or C++. We don't have Pascal, which RDB does. We've never made an embedded processor. But we do have module SQL like RDB. Again, here you keep the same code maintenance. Your embedded SQL program is maintained as before. Okay. So I guess I was getting eager before. I've told you most of this already. It goes through and one difference, for example, is that Mimer is very keen on primary keys. And because you actually have very short and fast performance access to primary keys. So we'll actually go in and look at your index structure and look at null attributes for columns to decide if a unique index can be converted into a primary key. So we have that type of thing also. Actually, this utility can also be used with a running system. You can see the index usage and what indexes are being used and how much by different parts of the system. Again, when we're, okay. And then you have the meme load. It takes the RMU export. You take the sequential file. You can actually do this so that we're using common formats. RDB is somewhat tricky with binary data. So there's one thing you need to figure out looking at your data, and that's what type of separator to use? Because they don't actually escape characters when they're outputting it through RDB. So we kind of messed around with that somewhat. That's okay. And the application source code. it goes through, here we're actually looking at specific embedded constructs as well, of course, because you're doing declare cursors separately from open cursor. Again, you have a script here. So for example, for COBOL, we have a script here that finds all the embedded COBOL files for RDB are called SCO as an extension. And the Mimer equivalent is ECO. So it actually goes through. You can give it directories with your source code and just give you new directories with the new source code. And here's a simple example of what a SQL statement that we have. We're doing in RDB, we're calling a function called NVL, null value, and they're doing a limit here that, we only want to see the first 3 rows. And in standard SQL lingo, this is coalesce and fetch first 3 rows only. So we're kind of doing all these translations on the fly and changing RDB specific stuff into standard SQL basically, because that's what we're using. And it leaves these comments in the code. So if you go into debugging or you're looking at this later on, you can actually see, was this particular statement changed or not? So you have a good kind of documentation of what the tool did, because it's this source code that you will continue to work from. So here's the source code migration chain then, where we have the RDB embedded source. We run it through the translator and we get the new code here. And this is where you eventually anyway will continue your development. Maybe you'll go around here a few times when trying this out. You're running then the Mimer embedded processor, you get source code, you compile and link that, and you get an executable program that you can use with the data and the schema that we got across. So this is really, we kind of really, with the system, complex or not, you actually run a couple of command procedures and everything just moves across, and you have your database running, everything set up, and your data load. So I'm going to talk a little bit about a customer case that we have in Mexico right now that are using these tools in their system. It's a company called Profuturo, and they're managing pensions for. I think there are about 5 companies in Mexico that manage pensions, and this is the second largest one. So they are investing the money into and keeping track of everyone's income every year and so on. So they have this database system. We're working together with a partner, ARS from Chile, that are actually doing the migration work. So we're not actually we're in the loop so that if they have any questions and so on, we help them out. But we're not actually ourselves doing the job. If you look at their environment, they have 56 databases today. And together in these databases, you have 2,560 tables. So it's a fair amount of data. And they have 11.4 billion rows of data. So that's what we're kind of throwing across here. And they have 3,000 embedded COBOL programs. So this is an excellent test bed for our new tools, obviously. And also to see that, I mean, here you're getting into every data type in COBOL. So we've actually added a few data types to COBOL. I didn't expect that to happen. A long time since we were doing COBOL stuff in our system. Yeah, so that's not a big deal for us. We actually went through what they call proof of concept, where they wanted to make sure that, okay, let's take a piece of the system and migrate it and see how does this work for us. And they had a program they were particularly concerned about, that they said, we want this embedded program to run. And so we actually used these automatic command procedures. We migrated this data. We did no hand by hand anything. We did not do any optimization of this specific program. It was just converted through this process. And you can see here that this program took 18 minutes to run with Rdb. And when they ran the same thing with the same data on the same hardware with Mimer, it took 3 minutes. So they were obviously very happy. And I think they're going to see this in many places. They actually had another less important thing they wanted to test. That was 2 times faster. So it looks like many operations are looking really good when you plug in our database rather than Rdb. So that's, we're really happy about that. It's also what we've been expecting. I mean, we worked really, really hard on performance systems. Okay. I'm just going to touch on some options here with regards to the migration here. Again, what we're seeing with our product is that you're keeping the database on OpenVMS. We're promoting this operating system. We love the operating system, and I think that it's actually a great platform for database service. And why move people? Oh, uh-oh. Let's go. Good. I think we're pretty much good. Yeah. So why move off of this great operating system when you can keep running it? With Mimer, you have lots of different options on the client side. For example, you have ADO.NET interfaces on Windows, and have JDBC, you have ODBC. We have Python clients. We have lots of different plugins for various. Other solutions actually change from embedded SQL to module SQL, and that will actually give you, they're actually adding an extra layer between the application, and they're kind of plugging their software into the middle, because they're talking C to Postgres, for example. And then but then you want to get it up to COBOL, it means that their software in the middle is actually doing conversion stuffs. But with the Mimer case, you just have the Mimer client and it's talking to the COBOL program directly. So you're not adding a lot of stuff in various layers here, but this is very direct solution. I think that kind of minimizes risks also. It means that we know how to translate this data between different formats and so on, obviously. So a typical migration, you start on an Itanium and you're using your application towards Rdb. You can then move it to Mimer SQL on the Itanium box, and you can kind of transfer your application over to this. So you can kind of start by testing out this without switching platforms or anything. not involving migration of your application in the first step, unless you want to. And then you could move the Mimer database to the x86. We've been on x86 with the production version for 2.5 years now. Considering others are soon to reach beta, I think that shows you the quality of our software and on VSIs, obviously. You can then move your application across and start using the database here. Or you could actually keep the Mimer database on IKMeme and move the application, or you can test them out in parallel. So you have these options of how to actually move to the different platforms here and how you want to do that. Yeah. So with this solution, you keep your database on OpenVMS. You can actually also move the database off to a Linux or whatever else if you like. So we're kind of thinking of this as an enabler for the customers to keep using OpenVMS. That's really important. We have a little offer here. If someone dares to try converting their RDB databases, we will help you out for 2 whole days. And just to see, you can get really, really far in a couple of days. Obviously, you will not make an entire migration, but you can really see where things are leaning and how easy and fast it is to set these things up. Setting Mimer up on OpenVMS is really, really simple, but if you don't know it, it's always a little bit of a hurdle. We will help you with that. And we can also learn more about RDB usage of applications by doing this. So there's something in this for us. Even though we've added lots of RDB syntax, there may be some queries we would like to support as well. So that's just a little bit about coming things. We've actually developed an AI-based SQL translator also. And we actually had a demo of this in the bootcamp in London. What it does is that kind of we took this was an Oracle SQL statement. We were not using Oracle Rdb since we already support that. So we were running that SQL query through the AI-based translator, and it produced a new version of this. And then it ran this SQL statement and got another error. And then it kind of went back thinking about this, and then it produced a second statement. So it's kind of iteratively improving this statement. And in the third iteration, it actually worked. And when it worked, it actually ran the program with both the Mimer system and the RDB or the Oracle system, and saw that, oh, we're getting the same data back. So you could actually also do a validation that it's supposedly doing what you intended. So we're doing some neat stuff within the AI community as well. We're actually also participating in a car fair in Germany right now, where we're showing how you can get the AI support for querying and talking to the database. So we're doing lots of different things on the forefront, as well as being the backbone and being a professional developer of these types of systems. So yeah, I think that's where we're going. I think it will take some time before you actually have AI inside your databases. Obviously, there are many potential uses for this, but I find that if you look at our customers, they're really conservative. I mean, they don't they want to decide more. They want to decide the exact join order, or I mean, the optimizer does this, but they're scared that they have these huge databases, so they really want the system to do what it did yesterday, not being too intelligent and coming up with new strategies on the fly is not what you're really looking for in production.
Yeah, I think your use case for translating SQL statements, is an excellent example.
Yeah,
you have to iterate until it gets something seems to work.
Yeah, yeah.
Simple results to see whether
Mm-hmm.
they match. So that's one where connection.
Yeah, and it's really nice to see that just because we've published our stuff on the web, our manual, mm-hmm. It actually knows about this. We've not really done any programming to speak of. I mean, you do program the AI, but it's not at this detail level. It's really, it's amazing, Okay. Yeah, so that was my talk for today. Yeah.